Good morning. Everybody hear me okay? My name is Mark Kessner. I'm doing this presentation on dust control here today. I'd like to thank you all for coming. I hope you find it interesting. What I want to do today is turn the lemon into the lemonade. You know, forget about all this regulation, air quality standards, all that kind of stuff, and try to look at some of the benefits of dust control. It don't have to be all gloom and doom. First of all, you can get more production if you do this right. My belief is good dust control is nothing more than good process control. If it's not going up in the air or spilling on the ground, it's going to go into your truck. It's going to go into a rail car. It's going to go into a barge, and you're going to be able to sell it. Secondly, higher profits. For example, if you're using a water spray system, okay, that water is going to go across the scale, and that system could pay for itself in a couple of years. Machinery can last longer. I mean, you can't convince me that idlers and bearings and all those machine components run better in a dusty environment. Better morale. I mean, I've been doing this for 30 years and I don't like going into these dusty old plants. I mean, I feel better when I got a nice, clean, safe working environment. Fewer accidents. Okay, if you can see what you're doing, if your vision's not obscured by dust, you're going to work safer. And finally, better health. Okay, this stuff is no good for your lungs, and if you're healthier, you're going to have fewer sick days. So there's definitely some benefits here, and what I want to talk about today are some control methods from the point of view of a good process control is nothing more than good dust control. So try to view this whole problem of dust control is not in terms of complying with air quality standards, but in terms of an engineering problem. How do you approach it from an engineering point of view? They're just two sides of the same coin. Now, let me go back here a second. I'll tell you a story about a plant we put a system into in Missouri about 20 years ago. And this old boy that owned the plant, he got slapped with a $40,000 fine for visible dust emissions. So he figured he was going to sue the state. He was going to challenge their authority to regulate his emissions. Well, that didn't work out. He had to pay the $40,000 fine. He had a $20,000 or $30,000 legal bill. And then he went to our dealer. And he said, you know what, I think I'm going to have to put one of them damn systems in. And we went down there, we installed it, and we finished up during the lunch hour. We had just turned that system on, and I mean, that plant went from looking like the one on the left to the one on the right. And so we were sitting in the lunchroom when Harlan came roaring up in his pickup truck, and he came into that lunchroom screaming, what the hell's wrong with the plant? What broke down? He said, well, Harlan, nothing broke down, there's just no dust. See, when he came back from lunch and didn't see that cloud of dust coming up from his plant, he thought the thing wasn't running anymore. And he said, I want you guys to get the hell off my property. He says, I'm not going to turn that damn thing on again until I see the inspector coming down the road. So we said, okay, you know, we got up, we left. And I didn't hear from Harlan for, another 6 months. I think it was March of the following year when he called me up to tell me that my damn system had broke down. He said, your pump cracked. And I said, well, only way it could have cracked is if you guys forgot to drain it over the winter. You know, if you remember, you threw us off the property. And not my fault if you guys didn't remember to drain the thing, but he wouldn't allow his people to touch the pump. So he wound up spending another $12,000 or $13,000 to repair the unit and finally get things in good working condition so he could comply with air quality standards. So this guy wound up spending, I don't know, between fines and legal fees and the equipment, probably $120,000, $150,000. And what I want to encourage you guys to do here today is to don't wait for the last minute. You know, don't wait until you get that citation. Don't wait until you get that fine, because I guarantee you'll wind up spending a lot more money than you need to on dust control. You know, try to get ahead of the curve. Try to develop a dust control plan. I mean, you see that photo on the right-hand side. A quarry is a pretty complex operation. There's a lot going on there. There's a lot of dust sources. It's really difficult to figure out how you're going to control emissions from such a complex facility. Where do I start? Well, the first thing you want to do is conduct a site survey. Where's that dust coming from? Okay, get out there in the plant and list all the dust sources. Secondly, you can estimate what your dust emissions are. your uncontrolled dust emissions. How much dust would that plant produce if I didn't do anything to control it? How much dust would I get from the roads? How much dust would I get from the piles? How much dust would I get from the crushing and screening plant? You can estimate all that stuff and come up with a baseline of uncontrolled emissions. And then you can sit down and put together a list of control measures. And you can pick the ones that are appropriate for your facility. It could be a simple enclosure, could be a spray system, could be a baghouse, could be some skirting, could be a dust curtain, whatever. List all that stuff. And by doing so, you're able to prioritize these dust sources. Your site survey and your calculations here have told you which are the most prominent sources, so that you can approach the problem by tackling the big, most prominent sources first and leaving the smaller ones, for later. Establish a budget. Okay, if you can get ahead of the curve, you've got the luxury of being able to figure out how much money you've got available to spend on this stuff. And try to do the least expensive things first. Okay, by taking low cost, low efficiency controls and combining them into a dust control plan, you can wind up with control efficiencies that are comparable to a baghouse and spend a third of the money. You need to implement the plan. Somebody's got to be accountable. Could be an environmental manager, could be a foreman, could be the plant manager, but somebody's got to be accountable for the results. And finally, you want to monitor the performance, not only to show the agency that you're in compliance, but just as importantly, to show your management you've been able to control these emissions within budget. Nobody likes to spend money on dust control. I've been doing this for 30 years, and it's like trying to sell disease, Nobody wants to do it until they have to, but I really encourage you to try to get ahead of the curve so you're not like that old boy in Missouri and wind up spending a lot more dough than you have to. Okay, so what I've done here, I've divided the dust sources up into 4 major categories. Okay, first of all, you got paved roads. Okay, carry out a silt onto paved surface becomes airborne. It gets re-entrained with traffic. Then you got your unpaved roads. Okay, dust is produced by the action of tires on the surface silt. Piles, wind erosion, stacking and reclaim operations, they all produce dust. And then material handling, processing operations, conveying, screening, crushing, stacking, all produce visible dust. Generally speaking, paved and unpaved roads account for roughly 35% of dust coming off a typical quarry property, piles for probably another 20 to 30%, and material handling for the balance. So it's a pretty even mix. But again, that's going to depend upon your particular situation. Everybody's a little bit different. Now, every state except California, I believe, allows you to use what are called reasonably available controls. And these are nothing more than common sense control measures. Okay, stuff that you've read about in the literature, stuff that you've heard about by coming to seminars like this, things you've learned by talking to your buddies in the industry and what they've done to control emissions. And I've divided them here into 4 categories. Okay, first you got operational controls. All you're doing here is teaching people how to do things differently. You're teaching your operators how to minimize dust. Okay, doesn't cost you a nickel. Okay, there's a right way and a wrong way to load a truck. There's a right way and a wrong way to dump a truck. There's a right way and a wrong way to operate a crusher. Okay, if you don't do it right, you're going to produce more dust than you need to. But it all has to do with training. Okay, you got to get your operators to take personal responsibility for controlling dust, and this can really make a big difference. And it doesn't cost you anything. Number 2 are engineered controls. Okay, and these are generally things that you can do with in-house labor and material. By engineered controls, I just mean controls that enable you to enclose and contain dust sources. You can get some, maybe you got some old conveyor belt and some steel sitting back there in your boneyard that you can use to button up a transfer point or to patch up a couple holes or to improve the skirting on a transfer point. All that stuff can make a real big difference. So operational controls and engineered controls you can usually do with in-house labor and material. And if you really make use of those, if you really emphasize the training and you take a good hard look at the engineering at these dust sources, you can really reduce your reliance on more expensive controls like wet suppression systems and dry collectors. Wet suppression systems, water is the most common dust suppressant used to control dust from roads, piles, and all kinds of processing operations. And then at the top of the heap, the most expensive, you've got collection systems, bag houses, cyclones, other collection devices. are very high efficiency, and they may be the only alternative for hazardous or reactive dust. But these are the kinds of things that you don't want to have to do unless you have to. So let's take a look at reasonably available control measures for each one of these sources. Okay, first let's take a look at paved roads. Number one, housekeeping. Keep the roads clean. If something gets spilled on them, clean it up before it gets tracked off the property. What you want to try to do is prevent carryout. The reason you're getting dust emissions from that paved surface is because that surface has gotten dirty. Okay, carryout from unpaved roads. Okay, vehicles track material out onto that paved surface. So some of the things you can do from an operational point of view, you can restrict access to paved roads. Okay, if you've got 5 or 6 unpaved roads coming into a piece of paved road, see if you can narrow that down to 2. Try to restrict the types of vehicles you have traveling on the road. Rumble grates can be used to loosen and remove rock, you know, with that transition when you're going from an unpaved to a paved surface. And we'll be talking a little bit later about wheel washes, how they can be used to clean truck tires before they enter on the paved surface. Mechanical sweeping, you know, brooms and that type of stuff really aren't very effective unless the road has been watered beforehand. You know, dry sweeping can sometimes actually aggravate visible dust emissions. Flushing washes the silt from the surface. And I'm not talking about having a tanker with a spray bar wet down the surface. I'm talking about actually flushing the silt off the surface. If you just water down that paved surface, as soon as that water evaporates, that silt's going to remain there. You want to try to flush the silt from the surface. And that can be done manually for small areas, like maybe a plant entrance, or you know, if you got a mobile tanker. Vacuum sweeping, this is the most effective method. Probably a lot of you folks already employ a contract sweeper. You know, it comes around, does your roads, got the little brooms out in front with a couple of spray nozzles to keep the dust down. In vacuum sweeping, if you're in a cold weather climate, a winter climate, like my area back in New York, it's probably the only alternative in cold or freezing weather. What the EPA recommends is wet vacuum and flush for the highest control efficiency. That'll give you, I think they estimate 97 to 98% control efficiency on a paved surface. Here's an example of a rumble grate. This is just some C-channel that's been welded together. These work fine until they get dirty, and it generally doesn't take them long to get dirty. You know, once stuff gets built up into that rumble grate, forget about it. Down here in Southern California, they passed a rule several years ago called Rule 1157, where every affected facility had to install a rumble grate and a wheel wash. Problem with that rule was it didn't say it had to work. So a lot of guys put in these rumble grates, okay, but they never kept them clean, but they still complied with the letter of the law, you know, and then you just dig a little hole and fill it with water. You got a puddle of water, and, you know, you're basically in compliance. There's no performance standard. But it depends on the area you're in. You know, if you're out in the middle of nowhere, maybe you don't need to do anything. Maybe you're in an agricultural area where the farmers are tracking out more stuff than you are. If you're in a metropolitan area, though, you know, you can be really under the gun, and you may have to install a wheel wash. Okay, there's 2 basic types. Okay, number one, you got basins. Okay, vehicles drive through a flooded basin. These can work well as long as they're properly maintained, and you got a way to clean out that basin to keep rock and silt from accumulating. The 2 biggest problems with this are keeping them clean and recirculating the water. If you're not able to recirculate and clean up that water, you wind up washing with muddy water, and, you know, it just don't solve anything. Second type would be a pressurized spray system. Vehicles drive through some sort of wash zone. Sprays could be anywhere from 40 to a couple hundred pounds of pressure. There's all kinds of designs for these wheel washes. Water can drain to a storm sewer, retention pond, or some other kind of basin. All of these wheel washes work. The biggest problem with these wheel washes are, number one, getting the trucks to drive through them. If you're going to put one of these things in, you got to make sure there's no way a truck can get around them, because they will. Number two is keeping their speed down, because these guys will go through there as quick as they can, okay? And if they just blow through a wheel wash, you're not going to be able to do a very efficient job of washing it. And then number three, you want to try to locate the wheel wash as far back in the plant as you can. If you have a scale house that's 800 to 1,000 feet back, from the public roadway and you got paved road from that scale out to the public road, those tires that get washed in that wheel wash, they're going to be dry by the time they get out onto that public road. On the other hand, you know, if your scale is right there and, you know, it's 50, 60 feet to the plant exit, you're going to track out a slick of water. I mean, the tires are going to look visibly clean. That slick of water is going to get tracked out of the plant and maybe extend for a couple hundred feet on either side of the plant exit. When that water dries, it's going to leave behind this microscopic silt, and then passing traffic, you know, is going to cause that to be re-entrained. So when you drive up to the plant in the early morning or in the evening when the sun is behind that stuff, it can look pretty nasty. So try to locate that wheel wash at a transition point from unpaved to paved surface. Okay, once those truck tires are clean, you don't want them going onto an unpaved surface. So once they're clean, they got to stay on pavement. And again, try to set them back about 1,000 feet, 800 to 1,000 feet to allow tires to dry before they travel onto a public road. At sites with high truck volumes, recycling clean water to the wheel wash can require the use of multiple sediment basins and weirs. This is a quarry in the St. Louis area. I think these guys have anywhere from maybe 600 to 800 trucks a day. And you can see they've had to put in 1, 2, 3, 4 settlement basins. So here's your dirty wash water, you know, comes into that first basin. There's the overflow weir into the second basin, another weir into the third basin, another weir into the fourth basin, and then, you know, clean water back to the pump. I mean, you're looking at, you know, a couple hundred, maybe 250, 300,000 bucks worth of concrete work and pumps just to handle the recirculation and cleanup of that water. Some folks use flocculants. I mean, that's fine. You know, all this stuff works. The big problem, again, is maintenance. Let's see. Okay, unpaved roads. Speed control. Speed control, lower speed means less dust. It's just common sense. Here's an example of an operational control that can really determine whether or not you're going to have a problem with your unpaved road surfaces. You know, for haul vehicles, it can be kind of tough to keep speeds down. I mean, you've got to get them up to the primary crusher in a certain period of time or you're going to run out of rock. On the other hand, I've been in plants where I've seen guys load up at the face and they blow 45 miles an hour down to that primary crusher with a trail of dust behind them, and then they'll sit there at that crusher for 5 or 10 minutes waiting to unload, okay? You got to train those guys. Keep your speed less than 15 miles an hour if it's possible. And, you know, if you don't have enough trucks, try to do the best job you can. Housekeeping, again, even though it's an unpaved road, if you spill something on it, try to keep the road clean. Try to keep it free from spillage. Shorten the routes. If there's any way you can shorten the routes that trucks travel in your plant, okay, that's going to mean less vehicle miles traveled, and that's going to mean less annual dust, less dust emissions over a year's period. Proper gradation, this is something that's often ignored. I mean, the reason you got a problem with visible dust from a road surface is because there's just too much silt. There's too much minus 200 mesh material on that surface. Maybe you could put down some chips or some larger aggregate that would decrease the percent of silt on that surface, and that might just solve your problem. If you still got a problem after doing all that, then you can take a look at dust suppressants. So again, you know, we're trying to move from low cost, low efficiency to, you know, more expensive stuff. To the extent that you can control speeds and you've got good housekeeping, you've shortened the routes, and you've taken a look at gradation on your road surface, you can decrease your reliance on dust suppressants. Water, you know, is the workhorse of dust control on unpaved roads. Low cost, but it evaporates. You know, if you're in the Gulf Coast area, you're in Houston where the humidity can be 80, 95, almost 100%. You can water a road and it might last all day. If you're out here in Las Vegas and it's 118 degrees, okay, that water's going to be gone in an hour, hour and a half. And you might have to have a water tanker going around that plant continuously to keep the dust down. Additives, surfactants. Okay, surfactants are just soaps that reduce surface tension. They allow the water to penetrate the road surface a little bit faster. They give you better wettability. Brines and binders, when you use things like these brines, these calcium and magnesium chloride brines, or any one of a number of chemical binders, you're actually trying to create a new road surface. Brines are chloride salts. The most common are magnesium and calcium chloride. I'm sure you all familiar with them. They're what we call hydroscopic. They love water. They suck water out of the environment, out of the ambient air, and keep that road surface moist. So they work best in areas where you've got relatively high humidity. Again, if you're out here in the desert Southwest, you know, these brines aren't going to be as effective because there's not as much moisture in the air, okay? Binders, these are chemicals, lignosulfonates, latexes, cutback asphalt emulsions. Those are probably the most three commercially important chemical binders for unpaved roads. Just about every sticky, gooey, gummy chemical you can think of has been used to control dust on unpaved road surface. I even tried blackstrap molasses once, which worked pretty well. Problem is you can't use oil anymore. You know, in the good old days you could put some oil down and that'd last forever, but you can't do that anymore. Lignosulfonates, they're a lot like oil. They're kind of a black, tarry, smelly sort of residue from pulp and paper manufacture. To use these, you may have to scarify and then compact the road surface. They're water soluble, so if you get a good rain, they're going to wash away. Latexes, these are acrylic latexes. They use acrylic latexes because they tend to, they're flexible. Years ago when I was in the business, we used to get off-spec paint from Roman Haas, sell that as a chemical for controlling dust from unpaved roads. Cutback asphalt emulsions really work pretty good. I just encourage you to contact your state DOT. A lot of the DOTs, you know, have a list of approved dust suppressants. If there's any way that you can use a waste product, you know, if you're in a major metropolitan area where you've got some steel mills or something like that, or a pulp and paper mill, maybe you can get some waste product that would be suitable for as a road dust suppressant. There's all kinds of vendors that sell these chemicals. And it's a very competitive market. You know, if you're thinking about using an additive, you know, it might pay to have one of these vendors come in and do it. Maybe they give you a free trial for a couple of months. And then you can bring another vendor in and maybe they can do a free trial for another couple of months, you know, and maybe you can go for a year or two doing free trials until you find a product that's going to work for you. If none of this stuff works, you're going to have to pave it. And that sounds a little bit extreme, but it's been done. There's a quarry in Newington, Connecticut. You know, it sits right in the middle of the little town of Newington, and they just had all kinds of problems with their neighbors. And they wound up paving that whole quarry. I mean, if you're driving in there to pick up stone, okay, you're on pavement. Okay, all the piles got concrete barricade blocks around the pile to prevent material from, you know, spilling out onto that paved surface. If you're loading up there, the loader comes over to the pile, he'll take a cut and lift his bucket, and if they see visible dust, that operator's instructed to call the water tanker who'll come down and water that pile before they load the truck out. It can get pretty nasty depending on who your neighbors are. And obviously paving's not feasible for haul roads and most stockyards. That quarry up in Connecticut's the only one I've ever seen pave their yard area. Higher silt contents and higher vehicle speeds increase visible dust, so again, it's important to take a look at the gradation of that road surface and train your operators to keep those speeds down. Watering is the most common method of controlling road dust. If you're thinking about using a chemical, what I'd encourage you to do is to take a look at whether or not that chemical can reduce the frequency of treatment to the point where it becomes more cost effective than water. I mean, you can calculate how much you're spending to have a guy in a tanker go around and water those road surfaces. If you can find a chemical that can reduce the amount of treatment to the point where it's more cost effective than water, then it makes sense to use it. And if they can't, you know, it doesn't. So it's all a matter of economics. I see more and more people going to stationary sprinkler systems. You know, it could cost you 60, 80, 90, maybe even $100,000 to have a guy in a mobile tanker driving around that plant all the time. More and more folks have gone to these stationary sprinkler system. As you can see from these photographs, they're not anything fancy. Luckstone in Virginia, they put in a couple of these, very sophisticated, and they work well, and they pay for themselves. You eliminate that water tanker, and now you got an operator who can get on to some more productive work. Okay, control measures for piles. Number one, you got methods to protect the pile surface. And again, training, instruct operators to minimize dust. Okay, if you're loading out a truck, okay, You go into that pile, you get that loader bucket in there, you lift it up, okay? And then you let it sit there, all right? Let that material spill back on the pile, okay? You don't want to overload that bucket, race over to the truck, spilling stuff everywhere before you dump it in. Try to do it carefully. It don't sound like it's going to make much of a difference, but believe me, it does. You got to take your operators got to take personal responsibility for minimizing dust. We usually find that it's also better to dump into a truck as quick as you can, okay? Because in the aggregate, you actually get less visible dust, less emissions up into the air. Okay, minimizing pile height. Okay, here's another example of, I guess, what I call an operational control measure. If you can keep those pile heights less than 10 meters, about 33 feet, you're going to have less wind erosion. Once you get over 10 meters, you get into what they call the winds aloft, you know, where wind speed is very much accelerated and wind erosion is aggravated. Engineering, if there's any way you can shelter that pile from the wind, if you can put it down in the pit or on the lee side of a hill or a berm that's going to reduce wind speed across that pile surface, that's going to help. Then you got wind screens and barricades. Okay, wind screens are porous screens. What they do is they reduce the velocity of the wind that's crossing over that pile surface. Barricades get the wind up and over the pile. And then number two, you got methods to stabilize the pile surface. Okay, these are the same kind of control measures you'd use for an unpaved roads. Okay, you can water the pile down. Control efficiency is not very high because in most aggregate processing operations, these piles are really active. And that also limits your ability to use chemical suppressants. Coal plants, for example, power plants, you know, they can purchase let's say they purchase some coal and they can put it into dead storage for 10 years, you know, they'll slap a bunch of binders on top of the surface and seal it against wind erosion, but you can't do that in most aggregate plants because those piles are too active. On the other hand, I've seen some plants that have enormous piles of fines, screenings that they can't get rid of. You know, that can be a real problem with wind erosion. If you've got a situation like that, it might be worth your while to look at some sort of chemical suppressant you could use to permanently coat that surface. I've even seen people hydroseed them, you know, grow grass and weeds on them to keep the dust down. Stacking material into piles causes visible dust. You know, drier and finer products produce more emissions, you know, and you can see here on a windy day when you're dealing with a fine product like ag lime, you know, these emissions can be pretty substantial. This is what wind erosion looks like on the pile. You can see how the wind has kind of come across, blown across there, and what that's done, that's blown dust off the surface. That destabilizes those larger lumps that, you know, roll down the pile surface and kick up more dust. So it's really kind of an insidious sort of deal. Aerial water cannons have been used to wet down pile surfaces to protect them from wind erosion. This is a photograph I took at a coal terminal on the East Coast. They've got this, I mean, they got millions of tons of coal in storage, and they've got this highly sophisticated aerial spray system. I mean, that's a 1,000 gallon per minute, you know, water cannon, you know, that's hooked up to a weather station, and it's pretty sophisticated. Can't do something like that in the quarry, but what you can do is go out to Home Depot and, you know, get yourself some rainbirds. You know, maybe that's all you have to do. If you've got a mobile tanker, we encourage you to put a cannon on top of it. That makes it a much more versatile vehicle because now you can use that cannon to water down a pile surface, or like it's being used here to clean spillage out from under that tail pulley. And then you got your these turbo-axial fans. They're equipped with very fine spray nozzles. They're modified snow-making machines. Some of these, I've seen them, they can throw 250, 300 feet. And they can be very effective at keeping a pile surface moist on a day when it ain't too windy. Okay, the problem with these things is when you need them most, they're least effective, and that's on a windy day. I mean, you get wind speeds up above 15, 25 miles an hour, how are you going to keep that fog targeted on the pile? Maybe you have to use an array of them. I don't know, but it can be difficult to use these things on a windy day. They were originally developed for demolition work. You know, if you're taking down a hospital or a department store or an apartment complex, you know, and you got your hammer banging that stuff down, they use these things to control dust during demolition activities. That was where these things got their start, and they've been generalized to include other applications like piles. Okay, so that takes care of roads and piles. Let's talk about material handling and processing. Again, first thing you want to do is implement good operating practices. Okay, train operators to take personal responsibility for minimizing dust. I cannot emphasize how important this is. And this was demonstrated to me years ago when we did a job at a transshipping terminal on the Ohio River. These guys would handle coal and coke and all these ferroalloys that were going up to the foundries and mills in Detroit. Trucks had come in. The Pennsylvania DNR insisted that these trucks be offloaded be loaded up in an enclosed facility. Okay, so they build a building, trucks come in this way, they go out this way, there's a ramp up the side, loader comes up the side, dumps into the truck. Pennsylvania DNR said, okay, we want you to put doors on either end. Okay, we want the truck driver to get out. Okay, the loader comes up there, loads the truck up. Still had some dust coming out of that bay door. So they said, we want you to put curtains up there, okay? Pull those curtains in so there's just enough room to get that loader bucket through there to load up the truck. So they did that. And the Pennsylvania DNR still saw some dust coming out of there. So they said, well, we want you to put an overhead spray system that's going to, whenever that loader passes through a photocell, an electric eye, the spray's going to click on, create a curtain of mist. It's going to contain that dust. So they did that. We put that system in there. And all this stuff worked really well. So I'm standing there with the plant manager, and we're watching this thing work, when all of a sudden this big puff of dust goes up behind one of the warehouses. Well, what the hell's going on there? It turns out some truck driver came in there. You know, his buddy was the loader operator. He didn't want to wait in line to go through that enclosed facility. It just took too damn long. He was in a big hurry up, so he said, why don't you just meet me in back of the warehouse over there? I just need a little bit of stuff. You just load me up and I'll get the hell out of here. So they did. The only problem was an inspector from the Pennsylvania DNR, just happened to be driving past the plant, and he spun in there and wrote him a $10,000 ticket. They'd done everything that they were supposed to do. They'd spent all the money they were supposed to spend. They complied in every way with that consent order. But they had an operator that was just dumber than a box of rocks, and he decided, he wasn't going to do it. And that's, 10 grand. All because they had an operator who didn't take personal responsibility for minimizing dust. So it can make a big difference. Okay, good engineering practice. Enclose and contain dust. Transfer points should be enclosed on 3 sides, fitted with a dust curtain and covered. Once you do all that from an operational and engineering point of view, then you take a look at spray systems to control visible dust. There's high pressure spray systems. These, I guess, are probably the workhorse of the industry. You've got fog systems, you've got surfactant systems, you've got foam systems. There's a lot of different stuff out there. All this stuff works as long as you've selected it for the appropriate application. And then finally, if none of that stuff works, you might be stuck with a dust collector. Okay, bag houses are the most efficient method for collecting the -10 micron, the PM 2.5, the respirable dust, and they may be the only alternative for reactive or particularly hazardous dust. Like if you've got a material with a real high silica content, okay, you may have to use a bag house, okay, because it can be a very hazardous dust. Okay, now believe it or not, good dust control, good process control are not mutually exclusive. I mean, good operating practice can help to minimize dust and actually improve production. And here's 2 examples. Number 1, choke feed crushers. Crushers make a lot less dust when they're choke fed. Good for production, good for dust control. And this is particularly true of impact crushers, especially vertical shaft machines. Now, if you've got a vertical shaft machine that's running 30–40% of capacity, it's just a big fan. And it's almost impossible to knock that dust down. Okay, so try to choke feed these crushers, just jam as much material as you can through them. Good for production, good for dust control. Number 2, try to avoid interruptions in process flow. I mean, I've seen some plants that were just they're just like Frankenstein plants, they're just a big mismatch of equipment, okay? And you got an impactor that's got a capacity of 800 tons an hour, but you got a really good deal on that scalping screen, but it's only rated for 300 tons an hour. So, there's the bottleneck, so, now you got to run that impactor at 300 tons an hour when it really wants to see 800 and it's just blowing dust. So maybe you're going to shut that down. Maybe you just run a bunch of material through there and when it runs out, you wind up with equipment that's windmilling. When equipment is windmilling, when those impactors are running empty, Usually you see this when you can't get rock up to a primary crusher in enough time. Okay, you got a primary impactor, you know, you only got one truck, you know, he comes up there and dumps a load of stone and, you know, through that machine. Then there ain't no other truck for maybe another 8 or 10 minutes. And all that time, that crusher's just spinning, and they can produce, emissions can increase tenfold when that machine is windmilling. So try to avoid interruptions in process flow, okay? And again, that's good for production. You want that plant just to be humming along. Good engineering practice. Here's some examples of enclosures. You want to enclose transfer points on 3 sides and put a cover on it. You want to have a dust curtain at the discharge to a conveyor. And you want to install dust skirts that provide a nice tight seal to the conveyor. And you may have to use dual skirts in some instances. Landscaping, I think this is something that's often overlooked. I think one reason you see more people putting the plants in pit is because they're out of sight, they're out of mind. You know, if the public can't see them, they're not going to complain about them. Again, you can use berms, fencing, or vegetation to shelter the plant from wind. If you're putting in a new plant, you know, take a look at the topography you're dealing with. Is there any way you can arrange that plant so it's going to be somewhat sheltered from the wind? And then you can also vegetate barren areas. You know, out here in the desert Southwest, you get these, you know, these little dust devils. You know, if you got areas in the plant that are barren, you know, maybe just dump some aggregate on top of them, or you know, maybe you can find something that'll grow there to help stabilize that surface and keep the dust down. So if you got an area that looks like this, I mean, if you got spillage underneath a screen tower that looks like that, you know, that indicates poor enclosure, poor seals. Workers that have to clean that kind of material out, that's when they really get a nose full of dust. You know, the poor slob that's got to go in there and shovel or bobcat that out. You know, that's when he really gets a good dose of dust. It ain't a fun job. We deal with a lot of new construction, and you know, the problem is when you get down to the short hairs, well, you know, we could put that skirting in, but you know what? We're not gonna do that. We're not gonna put the canoe. We're not gonna build that 10 feet out. We're gonna build it 5 feet out. We're going to try to shorten the conveyor lengths, you know, to save some money, but now we're loading too close to the tail pulley and you can't get a good rear seal. All that kind of stuff leads to spillage. More likely, skirts are worn out, you know, haven't been replaced. You get gaps that material can leak out of, and you wind up with something that creates a lot of spillage. Here's an example of an unenclosed transfer point. They just allow dust and spillage to escape all over. I mean, you can see a couple inches of daylight, you know, underneath that skirt board. I mean, you can put a spray system in here that's going to control dust. You can inundate that area with water, okay, but that's just going to make a wet mess. What you want to do is make it look like this, enclosed on 3 sides, okay, put a cover on it, put a dust curtain out there. I mean, that'll control 70 to 80% of the dust right there. And it's stuff that you can do with in-house material and labor. And it makes a big difference. Belt skirting, simple edge sealing system. I mean, most of you are familiar with this. I mean, they work well as long as they're properly maintained. You know, once they wear out, you got to make sure you replace them. There's several multi-layer sealing systems on the market now. I mean, they consist of there's your single edge skirt, and then they have here a flexible rubber that folds out against the conveyor. Okay, so that even if you got a little sag in between the idlers, okay, it's going to maintain a real good seal. This is the kind of thing you might want to put underneath a vertical shaft machine. I've seen vertical shaft machines. There's such horrendous air pressure in these things that they'll actually blow out a single edge skirt. They'll blow it right out over the side of the belt. Impact beds. Okay, we see more and more people putting these impact beds in, and one advantage is it helps to give you a nice, you know, nice uniform flat loading profile, and you get a much better seal with your skirts. Okay, you've eliminated those idlers where you can get that sag that you know, leaks dust and spillage. So these impact beds, you know, is something we highly recommend. You know, again, another example of an engineered control. So you don't have to add that nasty water. It's going to muck up your screens. Conveyor covers, they can help to reduce dust emissions, protect the material from the elements. I mean, all this stuff is a big help. I mean, you know, something like this is something that the public can see, okay? And that looks good when you got all your conveyors covered. All right, so let's now take a look at wet suppression systems. The advantages of wet suppression systems are, first of all, low capital costs. I mean, we're not talking about equipment that's particularly expensive. Generally low maintenance. Okay, basically all you got to do is keep an eye on the nozzles and an eye on the filters. Pretty simple. And they prevent dust. They prevent dust by reducing the potential of the substrate to emit particles. Okay, when I add water to stone, it becomes less dusty. Okay, so the idea here is to install a spray system that's going to be able to atomize the water into droplets that are small enough to suppress the airborne dust, but also add a small amount of moisture to the substrate, so it reduces its potential to produce dust downstream. Disadvantages, okay, can cause wet handling problems. Belt carryback, screen blinding, too much water can throw products out of spec, you carry too many fines over. They may increase crusher wear if you use too much water. Water spray systems obviously can't be used on water-soluble materials like phosphate, trona, or reactive materials like cement clinker. And they're hard to use in freezing weather. All right? As a practical matter, you know, a conventional spray system, you could probably use that down into the 20 to 25 degree Fahrenheit range. You know, much below that, those nozzle tips just start freezing up. And so it can be really tough if you got to run 24/7 in a cold weather environment. Types of spray systems for roads and piles. First of all, you got water tankers. Okay, they use to water unpaved road surface and flush paved surfaces. Water cannons. Stationary cannons can be used to water piles down. Water tankers equipped with a cannon, like I showed you in that one photo, they can be used to water piles, clean off production equipment, and flush off paved roads. Stationary sprinkler systems, again, these can be simple manual systems where you go out to Lowe's or Home Depot and get yourself a bunch of little rain birds and hook them up. Or they can be automated. You can get pretty sophisticated with this. Hook them into a weather station. They can be more cost effective than mobile tankers for longer unpaved routes. And then those fog fans that I showed you. You know, these are modified snowmaking machines. They can throw that mist a pretty good distance, and they can be used to control dust from roads and piles. Okay, and whether or not, you know, again, try to use the least expensive thing first. Every plant's a little bit different. Just because a guy down the street's got a fog fan that works for him doesn't necessarily means it's going to work for you. Every quarry's a little bit different. Now when it comes to aggregate processing, material handling and processing, you got 5 commercially significant systems available. First, the water spray systems. These produce an atomized spray to suppress airborne dust and add a little bit of water to prevent emissions downstream. Okay, these are water spray systems you're all familiar with. Fog systems. Okay, the technical definition of, when you say fog to me, that means a droplet that's under 10 microns. So a fog system is a system that can produce water droplets that are less than 10 microns in mean diameter. And you need high pressure to do that. Okay, these fog systems generally run at pressures of 800 to 1,000 psi. And they're designed to suppress airborne dust without adding any detectable moisture to the substrate. But they require a real high degree of enclosure. Okay, if you were going to install one of these fog systems, you need a high degree of enclosure so you can create a dead air space where those fog droplets and the dust particles can come into contact and settle out. You need real clean water because you're using really, really fine nozzles. And now you got a pump that's a positive displacement type pump. Okay, so it's going to require some regular maintenance. You know, for a conventional water spray system, these are generally centrifugal pumps that are self-lubricating that don't require any regular maintenance. So these fog systems can be a bit trickier. Air atomizing systems can also be used to produce a fog. I guess one of the more commercially important is the sonic system. These can create a fog by using compressed air, okay, at high pressure to atomize the droplets. They're just like a paint sprayer. Again, they're designed to suppress only airborne dust. They require a high degree of enclosure and also very clean water. Spray nozzles for a conventional water spray system, you could be talking anywhere from, I don't know, $3 to $20. For a fog system, you could be talking $12, $15. Air atomizing systems, now you're talking about nozzles that are anywhere from maybe 80 to 120, 150 bucks a piece or even more. And I want to emphasize that these fog systems and air atomizing systems, they're only designed to suppress airborne dust. They don't add any water to the substrate, okay? So let's say you're at a primary crusher and you've got a conventional water spray system. You knock the dust down there with that atomized mist and you add some moisture to it so that when it reports to that scalping screen, you don't see any dust coming off that screen deck. With one of these fog systems, you can install that fog system on that primary crusher and it can do a real good job of knocking the dust down there. But now you're going to have to put those fog nozzles up there on top of that screen deck because you didn't add any moisture back here to control dust up there. So with these fog systems and air atomizing systems, you've got to have nozzles at every source point. And that means a lot of nozzles and a lot of maintenance. Surfactant systems, chemical systems, these are systems that use a wetting agent, basically a soap. Okay, the soap allows water to wet and spread more efficiently and more rapidly. And they were developed back in the 1950s for coal mining. And coal is a very hard material to wet down. Okay, so when you got your water droplet here and your coal dust particle there, they collide, they come together. That water droplet can't wet down that coal particle. I mean, water beads on a coal surface, okay? Just like trying to wet a Teflon frying pan, okay? Water will just sit there in a little bead. And in this instance, what happens is that water droplet just bounces off of that dust particle. Can't wet it fast enough. So these surfactants are added to water to increase the rate of wetting, so that when that dust particle and that droplet collide, because that surfactant's there, it can wet down that dust particle faster. And Bureau of Mines did a lot of research in the 50s and 60s, and these surfactants could increase control efficiency of the water spray systems anywhere from 30 to maybe 50%. And they work well on hard-to-wet materials like coal, petroleum coke, sulfur. If you're crushing rock, it's a whole different story. I mean, rock is very easy to wet. Okay, so these surfactants are of pretty limited value. I don't see too many folks using them. The few that I do see using them are generally using them to satisfy permit conditions. You know, the state is, you know, you've gone to the state to apply for permits. You've said, I'm going to use a spray system with a control efficiency of 90%. And again, the state says, well, you know what, we read this article over here, we read this literature, says surfactants will improve control efficiency, and if you use a surfactant, we'll give you 95% control efficiency, which enables you to ratchet down your permit fee. So, okay, I'll buy a drum of surfactant, I'll install it, and as soon as I run out of that drum, I'm probably not going to reorder it, but at least I did it just to get my permit fee down. You know, don't get me wrong, these surfactant systems work, you just got to be real careful. If you've got a material that's difficult to wet, I'd say take a look at them. If you don't, they're probably not worth it. Foam systems. These are at the top of the heap when it comes to effectiveness and cost. Now these use water, a foaming agent, and compressed air to produce a low expansion, okay, a dry foam, just like a shaving cream foam. You can take it in your hand and you can, you know, peek it. Foaming agents basically shampoo. Sodium dodecyl sulfate is probably the most common. And these systems were developed originally for coal-fired power plants. Okay, back in the early 80s, these coal-fired power plants, they bring the coal in by unit train, they store it, they bring it into the plant, and they had to crush it and then pulverize it. And that crushing and breaking operation, that produced a lot of dust. And a lot of the utility companies at the time were using a system that was manufactured by Johnson March. And this was a surfactant type system, and it was a low pressure deal, and it added about anywhere from 1 to maybe 1.5% water to that coal. And the utilities didn't like that because that coal's going into their furnace, and you add too much water, it's going to affect their heat rate. So these foam systems enabled them to reduce water consumption, okay? So let's say I got a ton of coal and I got a gallon of water. Okay, it's pretty difficult to take that little bitty gallon of water and distribute that on that big old ton of coal. But if I can take that 1 gallon of water and expand it into 20 or 30 gallons of foam, it becomes a lot more easier to uniformly distribute moisture onto that coal. And that will enable you to keep the dust down. So the foaming agent is really a method of improving your ability to distribute moisture uniformly on a substrate material. Now there's some, the Bureau of Mines also did some work on this. They also found that, at least in underground tests they did, that these foaming agents seem to do a better job on respirable dust. And that's because these foam bubbles are under stress. I mean, I've heard some people have said, well, that foam bubble encapsulate that dust. That ain't what happens. Okay, what happens is you got this foam bubble and it's under a lot of stress. Okay, and when it collides with a dust particle, that bubble bursts. And when that bubble bursts, it shatters, okay, into tiny, tiny, tiny droplets. Okay, very small, 5 microns, 2 microns, 10 microns. Okay, and then those droplets scatter to suppress smaller particulate. So they were developed originally for these coal-fired power plants. The power plants loved them because instead of using 1% moisture, now they could get down to 0.1% moisture. And that foaming agent's an organic, okay? It's got BTU value. So the utilities go to their rate commission, the state commission, and they say, look, this thing is basically a fuel. We can pass that on to our ratepayer, okay? So really didn't cost them a dime. You can't do that in aggregate, okay? These things, you're probably looking at anywhere from 10 to 15 cents a ton to treat with foam. Again, I don't have any axe to grind. They work and they work well. I've seen some vertical shaft machines and some horizontal impactors, okay, where you just can't get water to work and this foam may be the only way to go. But they're expensive and they're difficult to maintain because you've got to have just the right balance of water, foaming agent, and compressed air, okay? And if you don't have that precise balance, you're going to lose that shaving cream consistently. So to tell you the truth, the maintenance is probably beyond the skill of most ordinary laborers, and most of you probably don't have enough people to maintain the production equipment, much less a spray system or foam system. But all this stuff works, and it's up to you to figure out which is going to work best for you. Okay, spray treatment points. And I'm going to talk here primarily about conventional spray systems because that's what does the work in 90% of the quarries in this country. Where do you put spray nozzles? You put them in hoppers, okay? Because that's where trucks are unloading. You need to have some way to knock that dust down when they dump. Crushers. Crushers are very prominent sources of dust. So spray treatment at crushers are critical. Not only because they're prominent sources of dust, but crushers are great mixing devices, okay? If you can get your water mixed in uniformly with the rock of this crusher, it'll report downstream to a screen, and if you got just that right moisture content, you don't have to put any nozzles up on that screen. You may not even have to retreat it until you recrush it. Screen discharge chutes, okay? We don't put nozzles on screen decks, okay? If you have dust, if you see dust coming off these discharge chutes when sized products, sized materials reporting to a conveyor, put some nozzles there. Stacking conveyors. If you got stacking conveyor that's handling a particularly fine product, you got an ag lime or something like that, you may want to put a spray nozzle out on the end of that stacker. And then transfer points. You know, if you have a few transfer points that are still a problem, you might want to put in spray nozzles there. But what I'm trying to do is encourage you to use as few spray nozzles as necessary because that means less maintenance. And I know there's some agencies that want you to put spray nozzles at every location, and you know that's the surreal world of plant permitting. I'm talking about the real world of plant operations. I'm just showing you here a typical layout, the process flow diagram for a typical primary circuit. Okay, so here you got your pump system, maybe you got a little surge tank. Line number 1 goes to that feed hopper. Okay, now if you've got a signal light that alerts that truck to dump, okay, as soon as that light goes green, you can tie that into the control relay for that solenoid there, and those nozzles will come on automatically. If you don't have a signal light, there's all kinds of detectors you can use to automate that operation. It's kind of difficult for an operator to do that manually because the guy who's running a primary plant, he's watching the crusher, he's watching this, maybe he's on the hammer. He just can't keep focused on that hopper when a truck dumps. So if he's got to do it manually, he might forget to turn the sprays on, and you get a cloud of dust, or he may forget to turn them off, and now you got a bunch of muck up there in that hopper. Second treatment point is going to be that crusher. Okay, here's where we're trying to control dust at that crusher, but add just enough moisture to that material so it's not going to produce up here on the screen deck. Okay, you don't see any nozzles up there. We got nozzles at the inlet, outlet. Maybe we'd put some here in this fines bypass chute, put one out here at this transfer point. Notice that each nozzle's got a shutoff valve. So within that spray zone number 2, you can adjust water consumption by opening or closing those shutoff valves. So, you know, once the plant gets used to a system like this, they know exactly which nozzles they got to use for a desired degree of suppression. Down here, zone number 3 of those screen discharge chutes in that surge pile. Okay, we got a nozzle out there to control dust when material discharges to that pile. Zone number 4 is that secondary machine. So you got 4 zones, you got a remote control panel up here with 4 switches on it. So the same guy who controls the production equipment, he controls the spray system, okay? So if something breaks down, he can shut the water off. If a hunk of metal gets stuck in that secondary crusher, nobody's got to go out there and turn a hand valve off, you just flip it off. If you got a manual system, you know, there's a Chinese fire drill trying to get that crusher back online, nobody remembers to shut the water off. That keeps spraying. Now you got puddles around the equipment, you got water on the belts, and it just creates a wet mess. So for a large stationary plant, it would really pay to use a system that can be remotely controlled. You can tie these things into your operator's touch screen. You know, they're real easy to automate. If you're thinking about designing a spray system, number 1, you want to use high pressure. And by high pressure, I mean 200 psi. 200 psi is about as high as you can go with conventional pipe and hose fittings. If you get much over a couple hundred psi, then you got to get into hydraulic hose fittings. It gets a lot more expensive. If you have a high pressure pump, you can size that pump to add a maximum of 0.5% by weight. Our systems, for example, our pumps are sized to add that maximum amount of 0.5% by weight. This corresponds to about 20 gallons per minute per 1,000 ton per hour of process flow. We found empirically that if you add more than 0.5% moisture in a typical aggregate circuit, you're going to start seeing reduced screen efficiency, off-spec material, maybe problems with crusher wear. You want to make sure that you've got a way to adjust. Want to make sure you got a way to adjust water flow in response to dust levels, like on that slide I just showed you. That can be done electronically by bringing spray zones in or out of service, or by a guy on the ground who can open or close the valves for individual nozzles. Electronic control, automation helps to reduce operator error and water consumption. And above all, if you're going to build your own deal, please, you know, buy a decent pump. You know, don't get to the Grainger catalog and buy the cheapest thing you can find. And the biggest problem we see with these plant design systems is that they just use cheap stuff that breaks down, okay? And the odds are, if it breaks down in 6 months, the guy who bought that stuff and put it together, he might not even be there anymore. You don't know where he got that pump. You don't know where he got this stuff. Heavy duty construction, really important. You know, you don't want to create another maintenance nightmare. You know, so make sure you get yourself a decent pump and use some decent materials at construction. Okay, here's how not to design a spray system. Okay, this is a major producer. I mean, the guys in the plant, they wanted to do the right thing, but they couldn't get the money for it. So what are you supposed to do? Well, I'll get a spackle bucket, I'll punch a bunch of holes in the bottom, I'll put a hose in there, and there's my spray system. Okay, problem is, I don't see any stone on that belt, okay, and that water's running. You know, when they switch that belt back on and a couple tons of water gets thrown up on that screen that's downstream, that's going to be a problem. Low pressure, it's a big problem. Low pressure pumps are cheap, okay, but at low pressure you can't get atomization, okay? If you're going to produce atomized water droplets that are capable of knocking down airborne dust, you got to have pressures that exceed at least 150 psi. Because what happens is at lower pressure, you can make water droplets, they're just too big. So you got a water droplet that's 1,000 microns in diameter, and here you got your little itty bitty 10 micron dust particle. Okay, so here they're coming together. Well, that little bitty dust particle just streams right over that big old water droplet. It's like trying to hit a mosquito with a bowling ball. Can't do it. And you can, you know, obviously here, this is operating at pretty low pressure. You know, you're not getting real good atomization. Here's a nozzle that's plugged. Okay, this one is partially plugged and just dribbling water. This nozzle looks pretty decent, but I can tell there ain't enough pressure. And again, why is this on when there's no material on the belt? Because it's manually controlled and nobody's going to walk 100 yards out there to shut the damn valve off. It's, you know, because they don't want to take personal responsibility for controlling dust and doing the right thing. High pressure saves water, okay? That's the bottom line. You want to get your water consumption down, get your pressure up. At 200 psi, high pressure spray system like this is going to add anywhere from 0.2 to 0.5% by weight moisture, okay? You want that operator to be able to add just enough water to control the dust, but not so much that it's going to cause downstream problems. I get into a lot of plants, and one of the first questions I'll ask a plant manager is if there aren't just a few days a year, maybe a day or two after a rainfall, you know, when the plant runs just right, when you can crush and screen and make all your products to spec and there's no dust. And probably 90% of the time I'll get a guy who says, yeah. And that tells me that there's some optimal moisture content, a process variable, okay, moisture. And if I can just keep the stone at that optimal moisture content, I can process it without any dust, and I can produce all my products to spec without any effect on screen efficiency. On the other hand, if he says, I don't care if we get 4 inches of rain, this stuff is always making dust, I'll say, thanks for your time, you better get a bag house. But in most aggregate plants, anywhere from 0.2 to 0.5% by weight is all it takes. But you got to have an operator who, you know, knows how to use the thing. Typical high pressure spray system, pretty simple. Here's your water inlet. There's a Y strainer. Take out any coarse grit or sediment. We put a flow switch on here in case your water supply is interrupted. That'll shut the pump motor down so it don't operate dry and burn itself out. Water goes around and back. There's a vertical stage centrifugal pump, gets boosted to 200 psi. You read that on your pressure gauge. And then here's your output lines, okay, with your solenoids. Line number 1 could go to a truck hopper, line number 2 to a primary crusher, line number 3 to a scalping screen, and so on. Then you got a drain valve and a pressure relief valve, or you can also use a restricted orifice. Basically, just think of a pump. Let's say this is a 40 gallon per minute pump. You got a loop of water spinning around 40 gallons per minute at 200 psi, and then you're just bleeding off whatever you need out in the plant. Any water that doesn't get sprayed into the plant just recirculates back to a surge tank. Remote control, this is an example of a simple remote panel. Again, I only show it to you to encourage you to use you know, electronic control. I mean, I see plants that, you know, cost $5, $6, $10 million, and they put in a jury rig spray system, you know, with a bunch of hand valves, and it just don't work because there's nobody around who's gonna, there's nobody on the ground. You got a sophisticated plant controlled by a computer. The same guy who controls the production equipment, he's got to control the spray system because he knows what's on and what's off. Crusher breaks down, turn it off. Interruption in process flow, turn the water off. Spray system automation, it's really very simple. Number 1, you can provide interlocking signals from switches or sensors like, you know, like that truck hopper. Put a photocell up there, an ultrasonic range detector, all kinds of devices. If you got a signal light, or an audible alarm, you can tie that in so that those spray nozzles come on when that truck dumps. Input signals, a lot of people take, you know, you're monitoring drive motor amperage, okay, so when the belt's loaded, it's going to pull more amps, okay, so that tells them, you know, that tells the spray system that belt is on and loaded, click the nozzles on. So pretty simple to do, and more people are automating these spray systems. Spray nozzles, these are the 3 types of nozzles we use. These fog jet nozzles, these are kind of like shower head nozzles. They've got a capacity of about 10, 11 gallons per minute at a couple hundred psi. You can project this mist 20 to 25 feet, and this is typical of what we use at a big truck hopper. All the nozzles we install in the processing circuit are generally these V-Jet flat spray nozzles. They come in all sizes and shapes. They vary in spray angle from maybe 25 degrees on up to 65 or 75. Capacities are anywhere from maybe 1/10 to 10 gallons per minute, depending on the kind of tonnage we have to treat. These V-Jet spray nozzles, a lot of people use full cone spray nozzles. The problem with those is they have an internal vane that spins the water, and you know, if you got it just makes that nozzle much more susceptible to pluggage. So these V-Jet spray nozzles, there's no internal elements, just a simple orifice. And then we also use these Foggit spray nozzles. Okay, these can be, we might use these at a loader hopper where you just don't need nozzles of the same high capacity like these Fog-Jet nozzles. Or if you want to just create a light mist over the top of a crusher, you know, one of these Foggit spray nozzles will do it. Spray nozzle installation. Number one, they should be pointed at the dust source. That sounds like common sense, but nozzles that spray onto belts or onto steelwork are just going to cause wet handling problems. Like you see nozzles, well, like that one photo I showed you, it sprays right down over the top of the belt. Okay, that's no good. All that does, wet down the material that's on top. When you got stone on the belt, you know, as that material shakes over those idlers, all the fines are going to settle down to the bottom. So if you've got a spray nozzle spraying down on top of that belt, stuff on top is going to get real wet. That water is never going to get down to the fines that are down here. And when you throw that stuff up onto a screen deck, you know, now you got the worst of both worlds. You got wet material that's mucking up the screen deck and dry material that's still producing dust. Even though you may be using the correct amount of water on a per ton basis, you don't have it properly distributed. Number two, they got to be seen. You got to be able to see these spray nozzles. If your operators can't see them, they ain't never going to change them. Also, obviously easy to reach. You know, if they can't get to them, they're never going to inspect them. They're never going to clean them. So, spray bar construction, again, real simple stuff. Galvanized plumbing fittings, some high pressure hose, little brass spray nozzle, unistrut mounting bracket. Here's installed a transfer point. Just burn a little hole through there. Keep that nozzle outside that hole. So an operator, I mean, I'm standing on the ground when I take this photo. I can see the spray coming out of there. If I had stuck that nozzle inside that chute, I'd have no idea whether it's working or not. And I ain't going to climb up there. So make it easy to see. An operator ought to be able to stand there and see whether or not you got any water coming out of that nozzle. Nozzle pluggage. To tell you the truth, most of the nozzle pluggage problems we see occur from the outside in. Okay, here's an example of an unenclosed transfer chute. This is a crusher discharge. So there's your nozzle. Okay, it's spraying mist at 200 psi back underneath that crusher, but then the air blast from that crusher is blowing wet mist and fines back onto that spray bar. You know, and you can see the kind of deposition that results. And that deposition is eventually going to cover that nozzle and clog it shut. So what we recommend is to put in a dust curtain. You know, put a little slot in there, locate the nozzle outside, so you know, again, an operator can see the water coming out of that spray nozzle, and that curtain protects that nozzle from all that blowback, making it much less likely to plug. If you're pulling water, you know, if you have a nozzle pluggage problem because you got sediment and water, there's all kinds of filters and strainers you can use to take that stuff out. If you've got stuff that's very hard water susceptible to scale, you know, call your Culligan man. There's all kinds of treatment options for hard, very alkaline water. So here's some guidelines for operating a spray system. And again, this gets to operator training. Turn spray lines on only when you see dust. Okay? Don't turn the spray system on if there's no dust. Now this can be hard to do. I mean, I've been in plants that have gotten, we do business with a lot of people that get fined or cited. That's why they wind up buying the equipment. Okay, and everybody's had the fear of God put in them because they've been fined $10,000 or $20,000 or $30,000. Maybe somebody's even lost their job. So now you go to that poor operator up there. He says, you know what? I'm turning everything on. I'm running this plant wet because my manager told me it's my ass, you know, if Mrs. Angelani over there calls the DNR on me because I got stuff all over the wash she's got hung out in the backyard. So you got to tell, you know, it's not just the equipment. You got to have an operator who knows what he's doing. Turn the spray lines only on when you see them. Use the water sparingly, just enough to control dust, not enough to cause problems with screen blinding or belt carryback. Turn the sprays off when the flow is interrupted. Don't leave nozzles running on because then you get wet belts and carryback. Add water as early in the process. If you can water down your shot rock, for example, that's a great thing to do because that'll help you minimize dust at that truck hopper. If you can water down your shot, you may not even have to use spray nozzles at your hopper. And adding water early on in that process can really help you to control dust downstream. All right, water you add in the primary circuit is really going to help you keep water consumption down in the secondary or tertiary plant. And then again, you want to use high pressure. Cold weather operation, here's a few guidelines. Install a thermometer, which an operator can read so he knows when temperatures are starting to drop, so he can take action before things freeze up. You want to make sure you inspect those spray nozzles every day. You want to make sure you inspect that pump every day to make sure that it's, you know, make sure that it ain't froze up. We just did a job, we did a job in New Jersey last November. And these guys bought a shed, and I told them, you got to put a heater in the shed. Well, they don't have line power in there. They got a gen set, so they don't have power over the weekends. But they said they'd rig something up, and I must have sent them half a dozen emails saying, don't forget to put a heater in there. Well, they didn't put a heater in there, and wouldn't you know it, that thing froze up over the winter, you know, and a brand new piece of equipment, you know, and all the plumbing split, pump split, had to rebuild the whole dang thing just because they didn't put a heater in that shed. So you want to make sure you inspect that pump, make sure it's in good operating condition. You also want to minimize the number of spray lines in service. Like on a cold day, maybe you're only going to use a few critical spray nozzles at your crushers. Okay, on a real cold day, you might not be able to use nozzles at a truck hopper because the wind could blow that mist back onto an operator's window and ice it up. Or you get ice on the wings, you get ice formation on some of your chute work, or you start to ice up parts of the belt. You want to reduce the number of nozzles in service in cold weather. Make sure nozzles are properly targeted so that they're not spraying on steelwork or conveyor belting. Want to be able to drain the hose lines immediately when they're taken out of service. If you drain the lines, make sure you leave that valve open. We've seen a lot of cases where folks drain the lines out. Well, you're an operator, it's out there, you know, it's 25 degrees and I'm waiting for this water to drain out of there. Well, the hell with that. I still got a few drops coming out, but I'm shutting that valve off. Okay, well what happens, a little bit of water settles in that drain valve and freezes up, cracks that valve. So when you drain it, leave that valve open, just remember to close it when you come back in the morning. Make sure that your hose or pipe runs straight and true, and drain valves located at all the low points. You know, any kind of loops or kinks are going to create areas where water can collect and freeze. If you truly need to operate continuously in freezing weather, really your only option is to heat tape, insulate, and jacket those spray lines. Okay, bag houses. Okay, when high collection efficiency on small particles is required, most widely used method is a bag house. Okay, just a big old vacuum cleaner. Advantages, high efficiency for finer particle sizes. Okay, these can operate at 99.9% control efficiency. They can generally operate in any weather. And they can collect water-soluble and reactive dust that you can't use spray systems on. And they constitute best available control technology. Okay. Disadvantages, high capital cost. Okay, you could spend 10 to 20 times the amount of money on a bag house that you would for a wet suppression system. High operating and maintenance costs, because instead of a 5 horsepower motor for a water pump, you got a 50 horse motor for the fan. And then dust disposal. What are you going to do with that dust after you collect it? You're going to dump it back into the process? Maybe you're just going to move your dust problem 1 or 2 transfer points downstream. Okay, got to figure out what you're going to do with the dust once it's collected. 3 major types of fabric filters or bag houses. I'm really only going to talk about this pulse jet. These are really the pulse jet is really the only one that's commercially significant anymore because they can collect and clean simultaneously. A typical bag house installation. You know, here you got your pickup hoods. Okay, could be a crusher inlet, crusher discharge, maybe a chute coming off a screen, whatever. Here's all your pickup points. Okay, the dusty air is conveyed back to your collection hopper. Okay, here's your filter media. These bags, reverse air is used to pulse those bags clean. The dust falls off into a hopper through an airlock, and then out for disposal. Okay, that disposal could be just dumping it right back on a conveyor, could be going into an auger and then dumped into a truck. Maybe you could, I've seen some folks install pelletizers, pin mixers, that type of thing that can be used to render that dust into a little pellet that's not going to be dusty anymore. Whatever the case, make sure you know what you're going to do with that dust once you collect it. And then obviously you got a big old fan that's creating a suction. Okay, problem is, well, before I get to that, one of the problems here is you've got to make sure that a lot of thought goes into putting one of these things in, okay? Spray systems are a lot simpler. Here you got a lot of engineering considerations, okay? You want to make sure that you don't have too many pickup points because they're difficult to balance. You know, I've seen plants, well, there's a screen tower over here where I need to install a bag house, and there's another one 80 feet over there, which also needs a bag house, but I don't want to spend the money on 2 bag houses. I'm just going to get one big old bag house, And like an octopus, I'm going to run all this ductwork to both of those screen towers. Well, that might work well for the first week, but very quickly, you know, the ducting gets out of balance. And once it's out of balance, it's almost possible to get that system back into equilibrium, and it's not working efficiently. So selecting a dust collector can be a real chore, and you may have to go outside and, you know, get a consultant in there or a vendor who really knows their stuff. You got to take a look at the dust concentration and particle size. You know, for a typical mineral processing operation, dust concentration can range from about 0.2 to 11 grams per standard cubic feet, real wide variation. Particle size can vary anywhere from half a micron to maybe 100 microns. How much dust, what degree of dust collection do you require? How efficient does it have to be? This depends on the health hazard of the dust, the plant's location, the allowable emission rate that you're permitted for, the nature of dust, and its salvage value. Characteristics of the airstream. Are you going to be handling something that's high temperature or something that could be corrosive? What are the characteristics of the dust? Is it going to, you know, do you have any clay in your rock, okay, that's going to make that dust sticky? That material can adhere to collector elements, you know, your fabric filters, and really plug these passages and really disrupt the collector's efficiency. And then again, you know, what are you going to do once you get that dust collected? You want to make sure you don't move that dust problem a couple of transfer points downstream. Common problems: undersized fans, okay, that don't have enough capacity to maintain the minimum velocity to keep dust from settling out in ductwork. You know, and this here is what you wind up with. And again, you know, it's a matter of cost. I really should put in a 50-horse fan, but you know what? Things are kind of tight, and I can get a good deal on this 30-horsepower fan. That's fine, but just remember, you're going to have to put up with this stuff. Sharp bends in ductwork. You know, putting in a 90-degree bend, that's pretty cheap, okay? It's a lot cheaper than it is to make a nice, smooth 90-degree bend. The problem with that 90, you know, with that sharp bend is that here's that dust is blown, you know, it's in the air, it's coming through that duct at high velocity. Those particles hit that wall, and they start to wear that out. All right, 2 months, 6 months down the road, you know, now you got a hole in your ductwork. So you want to try to avoid sharp bends. And then, like I referred to earlier, too many pickup points, okay, just makes it impossible to balance out these flows. And that's what makes them particularly difficult to use in an aggregate plant, because you've got so many sources in a typical material handling system. Okay, if you remember nothing else from today, remember this. Once you find dust controls that work, keep them working. Most of the violations, probably 90% of the violations that we see, are not because they haven't installed the right kind of equipment, it's because it hasn't been maintained. Spray system breaks down, baghouse system breaks down, the inspector comes in, says, oh, that pump ain't working. And your permit stipulates that pump has got to be capable of operating whenever the plant's in operation. So you got to make sure that the dust control equipment gets the same kind of maintenance that your production equipment does. Okay, again, good dust control, good process control. That really concludes my remarks today. I want to thank you all for your attention. We got a few minutes here for questions if anybody has an issue or wants to talk about a particular point of concern. Or no questions? Okay, well again, I thank you very much. Have a great day, have a safe trip home.